Hi girls. So this is me having a go at a relatively straightforward moles question from ordinary level Leaving Cert. This is 2017 question 2, so it'd be a good idea maybe to pause the video here and just dig that out, have a read of it. I'm going to just do the calculation part, okay? So hopefully you're aware that we covered the basics in the first clip, and in your notes in the folder there's all the information that you need, and I'm just really going through a calculation here for anyone who's struggling with that, okay? So I also gave you a template for this, and we're going to essentially follow that template, so it might be worth digging that out too. In the question, it gives you the concentration of HCl, so that's what we know, that's 0.1 molar. We know that we've used 25 centimeters cubed of the sodium hydroxide. Now, it doesn't give you the average volume of HCl, it gives you the 3 titration values, and as we discussed in the previous video, you ignore the first and you get an average of the other two. And when you do that, you get 19.55 centimeters cubed as the average volume of HCl. Okay, so I'm taking the second and third titration from the question, adding them together, dividing them by 2 to get 19.55. All right, that's where that comes from. Now, the first thing we're going to do is work out the amount of HCl that was actually used during this titration. So we've got 0.1 moles per litre. We're going to divide it by 1,000 and we're going to multiply it by the volume used, which is 19.55, to work out how many moles we actually used of this HCl. And when we do that, we get 0.02 moles, okay, or we get 0.01955, but I'm rounding it up to 0.02 moles. That's the amount of moles of HCl that we used during this titration. And that's our first step in our template that well, it's kind of the second step, isn't it, after we write out all the information, but you get what I mean. I'll write 2 there just to avoid confusion. So in the next step, we're going to use our molar ratio, and we're kind of lucky with this question here because the molar ratio is 1:1, which means that for every mole of sodium hydroxide that we used 1 mole of hydrochloric acid. We've just worked out that we used 0.02 moles of hydrochloric acid. So that means that there has to be 0.02 moles of sodium hydroxide in 25 centimeters cubed. So 0.02 moles of sodium hydroxide in 25 centimeters cubed. All right, in 25 centimeters cubed. Yeah, there we go. All right, now if the ratio there was 1:2, we'd have to multiply this by 2 or divide it by 2 depending, but it's not in this case, so it's actually a nice easy step. And the last step then that we need to do to get the concentration is we've worked out how many moles of sodium hydroxide are in 25 centimeters cubed, but we want the concentration, which is moles per litre or moles per 1,000 centimeters cubed. So all we do is we take that 0.02, we divide it by 25, multiply it by 1,000, stick that into your calculator, you get 0.08 moles per litre of sodium hydroxide is our concentration in moles per litre. Right, the final step it asks you to do is to change that to grams per litre. So you know, hopefully, when you're changing moles to grams, you need to go to your periodic table, work out what 1 mole of sodium hydroxide weighs. So you're going to find your sodium, oxygen, hydrogen in your periodic table, add up those masses, that's 23 plus 16 plus 1, which gives you 40 grams. So 1 mole of sodium hydroxide has a mass of 40 grams. What mass does 0.08 moles have? We're going to multiply 0.08 times 40, and that'll give us 3.2 grams per litre. Okay, so very important basic skills there for ordinary level questions. Really important that that you're able to do those different steps in our template and also convert from moles per litre into grams per litre. So I hope that helps. Let me know, go away, practice a couple of these, and let me know how you get on, and send any questions you have to me. Okay, thank you.